Welcome. This is a vodcast about solving triangles when you have side-side angle information. And as you recall from geometry, I first want to talk about just some subtleties about why this is a confusing situation. Remind you about some things from geometry. So I have an example here where I've got side-side angle information. This is kind of a special case. I purposely chose, this is a fixed 30-degree angle, and we've got some side along here that just extends out, this line extends out this way. And then we have a fixed side that's 10. And then over here, in this particular example, this opposite side of the 30-degree angle is 5. Well, hopefully you recognize that if that's 10 and that's 5 and that's a 30-degree angle, if I've got such a triangle where one of the sides is half of the other side on a 30-degree angle, that is a 30, 60, 90 triangle. So that's what we've got here. If I'm going to do this on each of these triangles that I'm showing you. So if I lined up this thing and like this side 5 would only touch at that one spot right there. So that's a right angle. So in fact, this piece of information would form a unique triangle, 30, 60, 90 triangle. In fact, this is what we called HL in geometry. I've got a hypotenuse, a leg, and an angle, a right triangle. So there's that situation. I'm going to keep changing the situation here. What if I have, just a second here. What if I have this, if I can get rid of that little, what if this opposite side is a bit longer? And let's say it's 6 or something like that. Suppose this side is 6. Well, if that's the case, then if I line up this compass and stretch it out there and draw an arc, that arc is 6 units away from that vertex up there, which means that this side here could either be there or could be over there. I could have that triangle with sides 6, 10, and 30 and an angle 30, or I could have this triangle with sides. Now, those are different triangles, so I'm not guaranteed with sides of side angle sides of 6, 10, and 30 degrees. I'm not guaranteed that I get that triangle. I could get this other triangle that I showed you, right? So that's the problem. Let's look at another extreme example. What if this side was way over here and it had a length of 12 or something? I don't know. Maybe it looks bigger than that. Maybe it's 15. Could I still form two triangles? Well, let's see what happens when I rotate this side of 15 around. I start here and I rotate it around and I get something way over there. It's actually going to be off the page, but it's no longer, I can't rotate it around and still preserve that angle 30 degrees. So these are different situations you can get with side angle. All right. Now let's actually try and solve some problems. Each of these problems is a side angle problem. So you have to recognize it. The first thing you do when you solve any of these problems is you draw yourself a picture. And it can be kind of a crude picture like this. But you want to get down the information. This is 13 degrees. This is angle A. Side A is across, so it's 12. And this is not a very good picture, but this is B, and this is 5, and this is C, and here's little c. So the way we're going to do this is we're going to use the law of cosines. You actually could set this up with the law of sines, but the law of sines doesn't give you as much information about which of those situations we were just talking about, what's actually happening, whether you've got 0 triangles or 1 triangle, 2 triangles. So let's set this up with the law of cosines. Well, I've got this angle 13 degrees, and if I'm use the law of cosines, that's going to go over there, and on this side, I would have to have the side across from it, which is 12 squared, and the other places I'm going to fill in the other sides. So that's going to be 5 squared plus c squared minus 2 times 5 times c. Now this equation is a quadratic equation. My variable is c. I've got a c squared in it. I've got a c in it, a plain c and a c squared, and then I've got some constants. So that means if I could get it into the form of ax squared plus bx plus c equals 0, and it's a little confusing, but in this quadratic equation, my variable is c, not x. But if I could set this equal to 0 and rearrange the terms, I could see maybe a little bit better. Whoops, let me put the 5 in here. And I'm rearranging this. Instead of writing 2 times 5 times c, I'm going to put the c at the end. So you can kind of see the variable in the right place. And then I had a 5 squared, but I'm moving it to the end, and I'm subtract 12 squared so I could have a 0 here. So this is my quadratic equation. We've programmed the quadratic formula in our calculators, and I'll pull that out in a second. But just to be really clear, I'm identifying the b is negative 2 times 5 times the cosine of 13. C is equal to 5 squared minus 12 squared. And we can just leave them just like that because these numbers, our calculator is really good at calculating and doing arithmetic. So we get out the quadratic program, press enter, enter in 1, negative 2 times 5 times the cosine of 13, enter 5 squared minus 12 squared, enter it all just like that, press enter, and I got 2 solutions. One of them is 16.82 and the other is negative 7.08. Well, you can't have a negative side to a triangle, so this is telling us that we have that situation where only one triangle can be formed. This side C is 16 point whatever that was, 16.82. 16.82 is C. Well, now I can figure out. I'm going to find angle B using this law of sine. So sine of B over 5 equals the sine of 13 over 12. Now notice I could have done that from the very beginning. I could have used the law of sines just like this from the very beginning, but it wouldn't tell me if I had 0, 1, or 2 triangles. So that's the advantage of using the law of cosines, as you'll see on another problem here. So I would do 12, no, I'm sorry, I would do 5 sine B is equal to 5 times the sine of 13 divided by 12, and take the inverse sine of all that stuff. 5 times the sine of 13, and you might write things down a little bit differently than I'm doing, but that's going to be angle B. And I get out my calculator again, and I do the inverse sine of 5 sine 13 divided by 12, and that is 5.38. Am I in the right mode? Yes. Just a small angle, 5.3 degrees. 5.38 degrees. And I'm going to store that in alpha B. And then I'm going to find angle C by subtraction. 180 minus 13 minus alpha B. 161.62 degrees. I'm going to store that in alpha C. Okay, now I have this triangle completely solved. Here's one thing that I'd like you all to be doing is um, solve that, save that over there. I'm going to show you how to check this. That I don't think a lot of students have been doing here, but would be a good idea. So this is 5.38. So one thing to check is the smallest angle, this is degrees. That's a little angle. That's a really big angle. The smallest angle is across from the smallest side. This middle angle, 13 degrees, is across from the middle side, which is 12. And the biggest angle, 161.62 degrees, is across from the biggest side. Let's see if this all checks out in another way, though. And that is, and I've got these stored values. I should be able to do sine of C sine of C. Get out of there. Sine of C divided by oh dear. Oh, that side is actually, I didn't tell you this, is stored in X from the quadratic formula. I got that. And I should be able to do the sine of D divided by 5 is the same thing. And the sine of A, which is 13, that's not stored anyplace, but it's just 13, divided by 12, which is also not stored anyplace, is 0.02. That tells me I did everything right. So that is a great check. All right, look at problem number 2. And that is also draw a picture. Now this side is 13. This is A. This is still 12. And now this side is 15. And I'm still solving. I still got a similar deal here. I'm going to set up this thing. I'm going to do this a little faster. This is 12 squared equals C squared plus 15 squared minus 2 times 15 times C times the cosine of 13. And I get 0 equals C squared minus 2 times 15 times the cosine of 13, C plus 15 squared minus 13 squared, and I put that in my calculator with the quadratic formula, and A is 1, B is negative 2 times 15 cosine 13, and 15 squared minus 13 squared. And I've got 2 positive answers, which means I have 2 different triangles that I can solve. Find a place to put that so I can look at it. So that means I have the triangle that I've got shown here, and this long side here would be the 27.17. So C can equal 27.17, or I have a picture that looks like this. These are not very well drawn, but I just need them to keep track of things. This is 12, this is 15, this is 13 degrees, and this is 2.06, and I'm going to solve both of those triangles completely. I need to find this angle C, and this angle B, and this angle C, and this angle B, and they're going to all be different. turns out that these two angle B's will be supplementary to each other. So think about that. Here is one more triangle. Let's see what happens with this. I'm going to do it kind of quick. This is 13 degrees. This is 12. And this is 60. And this is a really lousy picture. But if you set this all up, and this is A, and this is B, and this is C, and we're still solving for side C, and I still set this up with 12 squared here equals C squared plus 60 squared minus 2 times, I mean, you can maybe figure out already what's going to happen here is this doesn't look like a very promising triangle. It's not always going to be this obvious though, but if I set this equal to 0, and do my quadratic formula thing again, I'll show you what that looks like on your calculator, because it's not always clear to people. 60 squared minus 12 squared. So get out your calculator again, put in 1 negative 2 times 60 times the cosine of 13, 60 squared minus 12 squared. And this, you can see that these are complex results. Let me show you, let me do that one more time because I want to show you my calculator set up a certain way, and I want to show you with just, let me run those numbers again. 1, this is probably what your calculator, what happened on your calculator. Negative 2 times 60 cosine 13 and 60 squared minus 12 squared. And now it looks like this is a more typical way you're going to see. But you see that 58.46 with lots of decimals plus 6.1 dot 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 and 58.4 minus 6.1 dot dot dot. Well, that dot at the end of that dot 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 is an I, which means the quadratic equation is telling you that the solution to this quadratic equation are imaginary numbers. C cannot be an imaginary number for a side of a triangle. So in this case, we would say no triangle can be formed. No triangle. And that's it. Those are some of the situations that can happen. In this problem number 2, I didn't show all the work for solving the rest of those triangles, but it would just go through and use the law of sines and solve for the different angles. And remember to never ever find an angle that might be obtuse using the law of sines. All right, that's it.